This is a video about spatial join. What I've loaded up here is the familiar county of Oneida and its towns and villages and cities. And on top of that, I also have the agricultural districts of Oneida County, and we've seen this several times. Let's look at the attribute table for the ag districts of Oneida County. What it shows us is that there are 1,305 agricultural districts, and one notable attribute for each of those is the area. And what I'm thinking is it would be very cool. One thing I could do immediately that we already know is right-click on the column header and ask for statistics and discover the total number of agricultural districts and their total area, I assume in square meters, in all of Oneida County. You probably could figure out what the area of agricultural districts are in each of the towns of Oneida County, but with 29 subdivisions in this county, that process could become a bit tedious. And for larger data sets, it would probably be impractical to do. Spatial join is something that lets us figure out that type of information very quickly. So what I'm going to do is I'm going to use a spatial join to add up the areas of agricultural districts in each town and the number of agricultural districts in each town, all in one operation, one very quick operation. In order to do that, I'm going to actually be doing a join, spatial join. It's a join in that the attribute table of the minor civil divisions, towns and villages data set will become enhanced with information that comes from this other data set. So it is a join in that way. Let's go ahead and do a spatial join. I right-click on this. I ask for joins and relates and a join. And I right-clicked on MCD because that's the data set that is going to be joined to. It's going to get more information. In this case, I'm not joining from a table. I'm joining from another layer. I'm bringing information from the ag districts layer into this data set based on spatial location. So what layer am I going to join? What layer is going to be the outside data that's going to come into my attribute table for MCD? Well, in this case, it is the only one that's available. The only other layer is the ag districts. I'm joining polygons to polygons, and what I'm going to do is let's see here. I'm going to ask for each of the towns to have its attribute table enhanced by having the sum of the attributes that are found in the ag districts of Oneida County, and that attribute was area. Let's see. And I'm going to also suggest that in this case, actually I think these are alternate choices. So what I'm going to do here is I'm going to pick this particular choice. It allows me to do a sum. And let's see, and this operation will create a brand new layer, and it has to be stored somewhere. I'm going to just let it go to a temporary storage location for the time being. A copy will be loaded into my project when the operation is done. So I'm just going to say go ahead and do it. This is a more complicated operation. It does have to run through a lot of checking and computing, but it still is done pretty quickly. It gave it a lousy name. It's called join output. What join output is going to look like, it's going to look like the original file, the MCD, which it does spatially and in the attribute table, but there's going to be more good stuff in the attribute table. And what is going to show in the attribute table of our newly created layer with a join complete is all of the towns again, a count of how many ag districts fall within that town, and a sum of the areas, some of the fields that are created in this operation are not actually meaningful. The sum of the codes of the districts doesn't really make any sense. What is valuable is the count, which shows us how many ag districts are in each of the towns, just like that, and the sum of the area field of all of those ag districts. So what this is telling us is that in Ansville there are 80 ag districts, and their total area is that much. And this has been a pretty potent computation. There's some small room for error, and the results for Marshall and Deerfield might not exactly match those that you got doing this in a more tedious geoprocessing methodology, because I believe some of these ag districts actually cross town lines, and they probably got double counted. But that's just a minor detail in this interpretation. What's important for you to have seen is the concept of a spatial join and the method that was used to implement it. And we'll just sort of ignore the minor cases in which there was some kind of double counting that occurred. But that was a very, very potent computation that was just done in a very, very short manner.